All right, everyone, good day. Wonderful to see you here. But basically, today we will be looking at creating a scatter plot using seaborn and pandas. All right, creating a scatter plot using seaborn and pandas. And in this session, we'll be looking at key topics like what is seaborn, what is a scatter plot, what a scatter plot is used for, what is correlation, because we'll be mentioning that you will be hearing that term whenever you're trying to make a scatter plot or plot one. Then how understanding the basic parameters of the scatter plot, and also how to interpret a scatter plot. So now let's start from what is seaborn. So seaborn is a library used for visualization in Python, right? And we have different libraries for visualization. We could use Matplotlib and seaborn. I prefer seaborn personally because I'm confident using seaborn. Okay, so I'll just so I'm confident using seaborn. All right. So before we go ahead into our visuals, okay, we want to import our libraries. So importing our libraries before making our visuals is very key, very important. So the first thing we'll be doing is importing pandas as PD, importing NumPy as NP, and also importing seaborn as SNS. You could call yours anything, but these are like the commonly used aliases for this library. So we'll run this, and we are getting our data set from this website. So I would also run this. Then the next thing I want to do now is to view the data set, the first 5 rows of our data set, right? So now we can see we have features such as age, sex, BMI, steps, children, and down to claim amount. So the next question we want to ask ourselves is why scatter plots? Why are we using scatter plots? Why are we actually using a scatter plot? What is a scatter plot used for? Okay, so basically a scatter plot is used to graphically or visualize the relationship between two features. Okay, so which I have written here and is the most commonly used multivariate graphical method. So we have two different types of EDAs when it comes to data analysis or data science. We have univariate and multivariate. So we have univariate graphical analysis, univariate non-graphical analysis. For the univariate graphical analysis, we have things like histogram, density plots. Then for the univariate non-graphical analysis, we have stuff that we call the 5-number summary, that's descriptive statistics. Then we'll move on to the multivariate graphical analysis. We have stuff such as pair plots, we have scatter plots. Then for the non-graphical analysis, for the multivariate one, we have stuffs we call kurtosis analysis, we have skew analysis, we have correlation table. All right, but for this particular session, we'll be looking at the multivariate graphical method. All right, so scatter plot is used to see how correlated, okay, maybe when you have Mr. A and Mr. B, how correlated are these two people? What is the relationship, or what is that thing that they have in common? Right, so that thing that they have in common creates a bond between them. It's maybe you have two brothers, you notice that both of them are tall, both of them are dark. They don't have the same faces, right? So the amount of things they have in common tells you the percentage correlation that they have. So maybe they have, out of 20 stuff, they have 7 things in common. It can always tell you that maybe there's a 30% correlation between these two. Or maybe they have 17 stuffs in common. It can tell you that there's a 70% correlation, or they have 70% relationship status between those two people. Okay, so now dots and numbers, right? Now, a scatter plot is used to actually visualize these numbers. So for us to look at these stuffs in numbers, we'll use what we call a correlation table. Okay, I will just go ahead and make this. So now I want to plot a correlation table for this table we have here. Okay, we have age, sex. So I want to see how related these features are to each other. So I run this, And I can see that the numbers are kind of long, so I want to just round it up to 2 decimal places. Just to make this short. Okay, round it off to 2 decimal places. That's second precision. Then we can see here that BMI, the relationship between age and age is 1.0, which is normal because it's one feature, right? Everything here is everything there. So it has a perfect relationship. All right, but the relationship between claim amount and BMI is at 0.29, which means that there is a positive weak relationship between BMI, body mass index, and claim amount. So BMI same as body mass index. So what it means is that there is a 0.29 relationship between claim amount and body mass index. So we have different types of relationship status. We have positive correlation, positive strong correlation. Then we have positive weak correlation. We have negative strong correlation and negative low correlation. Okay, so when we talk about negative low correlation, we can see something like 0.68. It's a negative figure and it's really low. It's far from 1, right? It's far from 1. So then when we look at something like 0.29, we can say that it's not close to 0.5, but at least it's far from the negative value. It's far from 0. So it's positively correlated, but it has a weak positive correlation. So if we want to make a visual of this stuff using a scatter plot, I would explain better using a scatter plot. So we know that particular that is a correlation table which shows us the relationship in numbers, right? So now what if we want to view this relationship between BMI and claim amounts? We want to view this relationship between BMI and claim amounts using a scatter plot. All right, so I'm going to explain the parameters. Now, what this means is that we have to understand the basic parameters. So remember we called seaborn as SNS. All right, so we're saying SNS.scatterplot. We're telling seaborn that, see, I want you to make a scatter plot for me using these parameters that I'll be giving you. All right, so X simply means we are putting BMI as the X axis. Y simply means we're putting claim amount as the Y axis. Then this data means where are we getting this information from? We're getting this information from our data sets known as DF. We called it DF, okay? That's a variable name we gave to our data set. So if we decide to run this, now we can see that from that correlation table, 0.29, there's no good linear relationship between these two. Okay, if we had, assuming we had 0.78 as the correlation figure here, we'll see that the figure will be almost a linear relationship. Okay, I can prove that to you by bringing this and maybe plotting BMI against itself. Okay, so I want to show you what it means to have a good linear relationship using. So let's look at these two plots. We can see here that the relationship between claim amounts and BMI is close. What this means is that we have someone that's at 50 years, probably has someone that's at 50 years probably has, let's say, a BMI at a very low amount at the normal threshold. Now, what this is telling us is that the person's claim amount, the person probably has no insurance claim, the person has no savings or something, or the person is healthy enough not to have an insurance claim. But yet, we can see someone that is at his 30s having an insurance claim at close to $60,000 or 60,000 rands or 60,000 naira, depending on the figure it is you're working with or the currency it is you're working with. Okay, so probably the person has been working from 20 years, worked 15 years, or worked maybe 19 years, and is able to afford an insurance claim because the person notices that his or her BMI status is really above the normal level. So the person went for an insurance claim, health insurance claim. Okay, so why this is not linear is because it's not certain to say that people in their 30s or people in their 40s should be getting insurance claim. It's advisable, but the data we have is saying otherwise. Okay, so that is why we have different people in their 50s having insurance claim, people in their 40s not having insurance claim. So it's the data is kind of uncertain. It's telling us that it doesn't mean anything that you're in your 40s, and it doesn't necessarily mean that you're going to have an insurance claim. All right. But now, if we look at the BMI against BMI, showing us a perfect relationship. Remember what I said. When it's closer to 1, the scatter plot tends to form a linear shape. By a linear shape, we mean that it starts from the origin, which is 0 here, and then extends towards the far end of the y-axis. Okay, so now we have the y-axis towards the far end. So we can see a straight line. What this straight line means is that there's a perfect linear relationship between the x-axis and y-axis. And why is that so? Is because we are plotting BMI against BMI. Assuming we had a feature known as maybe weight and height. Weight and height, definitely, we know that they have something to do with BMI, body mass index, because the formula for body mass index is weight divided by height raised to power 2, right, squared. So if we're looking at the correlation table between weight and body mass index, we are going to see a correlation between maybe 0.7 and 0.8, because your weight automatically determines your body mass index, and your height has a way to determine your body mass index. So if you're overweight, if your weight is, let's say, 502 pounds, automatically your body mass index should be gearing towards overweight or being obese. All right, so that is what it means. And if we decide to plot the weight against the body mass index in this figure here, we'll be getting something close to this, just that we are not going to have it in a perfect straight line. We could have some stuffs touching, maybe some dots moving outside the straight line. What that would simply mean is that maybe these are bodybuilders. I mean, if you're a bodybuilder and you're having a weight of 203 kg, it doesn't mean you're insane. It just means maybe you have a pack of muscles or something like that. All right. So this is what it means interpreting. This is how to interpret a scatter plot. All right. So in this video, what we looked at is we touched on what is seaborn. We explained what a scatter plot is. We explained what correlation simply means. We also explained the basic parameters, all right, using plotting a scatter plot using seaborn. We also explained how to interpret a scatter plot. All right, so there are different ways we could do this. We could plot a scatter plot. We could decide to use hue, maybe insurance claim as a hue, whereby we want to see those that are likely to actually have insurance claim. Looking at the data we have, we could use a color palette. Determine seaborn allows us to use a color palette, so we can go ahead to use different stuff. But this is a basic knowledge of how you need to plot a scatter plot, regardless of the data you're dealing with. Right? Thank you, and I'll see you in the next one.